Okay, now we're going to look at lesson 8.5, solving systems of equations by multiplication. And of course the objective is to solve the systems of linear equations by multiplication. Let's read through this, and we'll also do the ongoing assessments together, and then of course we'll review this in class. So on page 469 it says, Rachel works as a chemist's assistant for an experiment. Rachel needs 25 gallons of 24% alcohol solution. She has two solutions available, a 20% alcohol solution and a 30% alcohol solution. How much of each solution should Rachel mix to get a 24% alcohol solution? Now, it says in the last lesson, you used addition and subtraction to solve systems of linear equations. This resulted in the elimination of one of the variables. However, most of the time the variables are not opposites, and another step is needed. When none of the terms are opposites, we use the multiplication property of equality to multiply both sides of an equation so that opposite terms will result. The sum of these opposite terms will equal 0, thus eliminating a variable. Alright, so when we were doing addition and subtraction, we were able to eliminate a variable because one of the variables in each equation were opposites, so we were able to eliminate them. This is saying that most of the time you will not have opposites, and you have to use the multiplication property of equality to multiply both sides of the equation so that the terms will result in opposite terms. So in example 1, solving by multiplication, it says refer to the information given at the beginning of the lesson and write and solve a system of equations to find the amount of each solution Rachel should mix to get a 24% alcohol solution. So you'll let X represent the number of gallons of 20% solution and Y represent the number of gallons of 30% solution. The total number of gallons of the 24% solution is X plus Y equals 25. Alright, so she needs 25 gallons if you look back up at the top of the page, and of a 24% alcohol solution, and she has two solutions available, a 20% alcohol solution and a 30% alcohol solution. So X is the 20% solution and Y is the 30% solution, and that has to equal the 25 gallons of the 24% solution. Alright, turn the page to page 470. The alcohol in the 20% solution, 20% of X gallons, puts the alcohol in the 30% solution, 30% of Y gallons, plus the alcohol in the 30% solution, which is 30% of Y gallons, must equal the total alcohol in the 24% solution, which is 24% of 25 gallons. So 20% X plus 30% Y equals 24% of 25, or 0.20X plus 0.30Y equals 6, because 24% or 0.24 times 25 is 6. Okay, so let's see. So Rachel must solve the system of equations X plus Y equals 25 and 0.20X plus 0.30Y equals 6. Okay, so first you multiply each side of the second equation by 100 to eliminate the decimals. So you multiply each side of that second equation by 100 and you get 20X, because 0.20 times 100 is 20, plus 30Y, because 0.30 times 100 is 30, equals 600, because 6 times 100 is 600. If you multiply each side of the first equation by 30, both equations will have 30Y as a common term. Okay, so now you're trying to get a common term. So you can multiply each side of the first equation by 30. And as you can see there, they did that, and they have 30X plus 30Y equals 750, because X times 30 is 30X, Y times 30 is 30Y, and then 25 times 30 is 750. Now you can use the subtraction method to eliminate 30Y. So you're going to use the subtraction method and you get 30x minus 20x, which equals 10x, and 30y minus 30y, which equals 0, and then 750 minus 600 equals 150. So the result is 10x equals 150, and then you divide by 10 on both sides, and you get x equals 15, because 150 divided by 10 is 15. To find y, substitute 15 for x in the first equation, and the result is y equals 10. So again, just like we've done when we've done the subtraction, addition method, and the substitution method, once you find your first variable, you take what you found your first variable to be, and you plug it back into one of the original equations, and you figure out what your other variable is, and that's all they've done there. They plugged 15 in for x for in the first equation, and they got 15 plus y equals 25. Then they subtracted 15 from both sides, and they got y equals 10, because 25 minus 15 is 10. Okay, thus Rachel needs to mix 15 gallons of the 20% solution and 10 gallons of the 30% solution to get 25 gallons of the 24% solution. Now, for the ongoing assessment, it says, solve this system of equations using multiplication and then addition. Okay, so they give us 3x minus 5 equals y, and then 5 equals 5 equals x minus 2y. Alright, so I'm going to write these the way that we are used to seeing them. When you do that, you get 3x minus y equals 5. And all I did here was move some things around so that we have an equation like we're used to seeing. So the 3x stays the same. I added 5 to both sides, so I have a positive 5 over there, and then I subtracted y from both sides, and so I could get the y over here. And then we have already the other one is the right way, so x minus 2y, we just need to write it the right way, equals 5. And really, it doesn't matter, but this is the way you guys are used to seeing it, so I wanted you to see it this way. Now we need to use the multiplication method to get one of our variables to be the same. And if we multiply this equation on both sides by -2, we will get we'll have two opposite variables that we can eliminate one when we use the addition method. So when you multiply each side by 2, I'll bring this down here, you get -6x, and then -2, that's -2 times 3 gives you the -6, and then the x, and then -2 times -y equals positive plus 2y, because a -2 times -1 is a positive 2. So you get 2y, and then that's equal to -10. Okay? And then of course you just bring down that other equation. It stays the same. You don't have to do anything to it. Alright, and now we're going to use the addition method. So when we use the addition method, we get -6x plus 2y, and we'll put that in parentheses, plus x plus -2y, and that's equal to -10 plus 5. So we're just adding both sides of the equations, okay? And as you can see, you have a positive 2 and a negative 2, okay? So positive 2 plus negative 2 is going to give you 0, so those are going to be eliminated. And then negative 6x plus 1 will give you a negative 5x, and then I said the 2y and the negative 2y are eliminated, so that's plus 0 equals negative 10 plus 5 is going to be a negative 5. And then your so then you get negative 5x is equal to negative 5, and then of course you divide on both sides by negative 5 to get rid of the negative 5, so you have x by itself. And so x is equal to 1. And that's the first part of your solution. Alright, so I'm going to erase this. I'm going to put the first part of our solution up here. We figured out that x is equal to 1. Alright, and so now we need to find our y. So now we can say 3 times 1 minus y, and remember I just changed that equation around, equals 5. Okay, so 3 times 1 of course is 3 minus y equals 5. Okay, minus 3 minus 3, you get a negative y is equal to 2, and of course we need what y is equal to, so the opposite of 2 is negative 2, so y is equal to negative 2. So our solution for this system of equations is 1, negative 2, and we used the multiplication property of equality, and then we used the addition method to find this solution. Okay, and then it says under critical thinking, to solve Rachel's system of equation by addition, what number should be used to multiply each side of the first equation? So if you were going to use addition for that problem, you would need to multiply the first equation either by negative 20 on both sides or negative 30 to get a variable that is opposite from the other variable so that you could eliminate one. Okay, now let's go to page 471. For example 2, it says solve the system of equations. 2x plus 3y equals 0 and 3x plus 2y equals negative 5. The solution says one way to solve the system of equations is to choose multipliers that will result in equal coefficients of x. Multiply the first equation by 3 and the second equation by 2, then eliminate a variable by subtraction. So if you see there, they have their equation. They multiply the first one by 3 and the second equation by 2. Okay, when they multiply the first one by 3, they get 6x plus 9 equals 0. And when they multiply the second equation by 2, they get 6x plus 4y equals negative 10. And now when they use the subtraction method, they can eliminate one of the variables, the x variables. Okay, and so then they get 6x minus 6x is 0, 9y minus 4y is 5y, and 0 minus 10 is 10, and so therefore y equals 2. It says substitute 2 for y and solve for x in the first equation. 2x plus 3y equals 0, so you substitute 2 for y there because you found out that y is equal to 2. 2x plus 3 times 2 equals 0, and then 2x is equal to negative 6, and then because they found out that 3 times 2 is 6, and then they subtracted 6 from both sides to get the negative 6, and then you divide by 2 on both sides and you get x is equal to negative 3. You can check it by going back to the original equations, plugging in your x and your y variables that you solved for, and making sure that those come out correctly. Now let's look at this next ongoing assessment. So in the example, they eliminated the x variable. For the ongoing assessment, they want us to first eliminate the y variable. And so what you have to do here is you have your two equations, 2x plus 3y equals 0 and 3x plus 2y equals -5. And instead of, as you see in the example, they multiplied by 3 in the first equation and 2 in the second equation. This time, let's see if I can do this, you're going to multiply by 2 in the first equation. Okay, and then you're going to multiply by 3 for the second equation. Alright, now when you do that, 2 times 2 is 4, so you get 4x, and then 2 times 3 is 6 plus 6y, and then 2 times 0 is 0 equals 0, and then you get 9x plus 6y, because 3 times 3 is 9, and then 3 times 2 is 6, equals -5 times 3, which is -15. Okay? Now, you are going to be able to eliminate then the y variables, because you have a 6y and a 6y. And when you subtract, and we probably should have them reversed, so this one should be on top of the other one. But let's do that. Let's just bear with me for 1 minute. I'm sorry. Just so we can subtract this better. I'm just going to reverse where these are. So, uh-oh. Of course. It's erasing everything. Okay. Let's start over here. Okay, so we're multiplying this by 2, obviously. Gone through this already. We're multiplying this by 3. Okay, so I'm just going to reverse these, so I'll have 9x on top. It'll just be, you can subtract that easier, times 6y equals -15. And then 4x plus 6y equals 0. Alright, so subtract 9x minus 4x will be 5x. 6y minus 6y will be 0. And then -15 minus 0 is -15. So you get 5x is equal to -15. Then you divide by 5 and divide by 5, and you get x is equal to -3. Okay, and that's the first part of your solution. You take the -3 back up to your original equation. 2x plus 3y equals 0. You get 2 times -3 plus 3y equals 0. 2 times -3 is -6. Plus 3y. Oof. is hard to do sometimes. Equals 0. Okay. Then you add 6 to both sides. And you get 3y equals 6. And divide by 3 to get y by itself. And you get y equals 2. So the solution for this system of equations is negative 3, 2. Okay? And you found that out as well in the example 2. But in the example 2, we multiplied to eliminate this x variable, and in the ongoing assessment here, we multiplied to eliminate the y variable. And then in critical thinking it says the combination of the addition, subtraction, and multiplication methods are sometimes referred to as the elimination method. Explain why. And that's simply because you are usually, in all cases, you are eventually eliminating one of the variables. So that's why the combination of those methods are called the elimination method. And that is all. We'll discuss this in class some more and work on it with some of your packet that you have. We'll get you more work to help you understand this better. Alright, if you have any questions, write them down. Let us know in class.